Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. EZ isomerism requires assigning CIP priorities to the two substituents on each carbon of the C is equal to C double bond. The E isomer has the two higher priority groups on opposite sides of the double bond. General approach: for each option, assign CIP priorities to the substituents on each sp2 carbon, then determine whether the higher priority groups are on opposite sides, E, or the same side, Z. Option A: left carbon, cyclobutene ring versus cyclohexyl. Right carbon, cyclopropene ring versus cyclohexyl. On the left carbon, the cyclobutene ring contains AC is equal to C, higher unsaturation, higher priority by phantom atoms rule, has higher priority than cyclohexyl. On the right carbon, cyclopropene, three-membered ring with double bond versus cyclohexyl, cyclopropene has higher priority. Looking at the drawing, both higher priority groups, cyclobutene on left, cyclopropene on right, appear to be on the same side, both above the main chain, making this Z. Additionally, both cyclohexyl groups are on the same side below. Option B: left carbon has two heterocyclic rings containing P and S, right carbon has two heterocyclic rings containing O and S. Priority assignment: on the left carbon, the ring with P, atomic number 15, versus a ring with P, need to differentiate by ring size or substituents further. On the right carbon, S containing rings compete. This is complex, but the arrangement drawn places the 5-membered rings above and 6-membered rings below on both sides. Same side arrangement of same-sized rings suggests Z. Option C: left carbon, 5-membered dioxylane type rings with O atoms, atomic number 8. Right carbon, similar oxygen containing rings. The arrangement shows both larger higher priority groups on the same side, suggesting Z configuration. Option D: left carbon bears two cyclopropane-derived substituents, a bicyclic spirocyclopropane, two cyclopropane rings fused, effectively higher priority due to more carbons at first point of difference, on the upper left, and a cyclopropene on the lower left. Right carbon bears a cyclopropene, upper right, higher priority due to double bond phantom atoms giving higher CIP priority, and a cyclopropeno, lower right, of gives very high priority via oxygen. Assigning priorities: on the right carbon, cyclopropeno has higher priority, oxygen, atomic number 8 carbon. On the left carbon, the bicyclic spirocyclopropane has higher priority than cyclopropene by CIP rules, more carbons at first shell or phantom atom comparison. In the drawing, the higher priority group on the left carbon, bicyclic, upper left, and the higher priority group on the right carbon, cyclopropeno, lower right, are on opposite sides of the double bond. This is the E configuration. Options A, B, and C have their respective higher priority groups on the same side, Z. Only option D has the higher priority substituents on opposite sides of the double bond. Therefore, the correct answer is D. Therefore, the correct answer is option D.